let's see if you can apply the Gauss trick to a slightly different series. So let's say we have n terms starting at 1, but now instead of counting up by 1s, we're counting up by 3s. So 1 plus 3 is 4, plus another 3 is 7, plus another 3 is 10, and so on. So if you're going to use the same trick, let's take this series, let's write it again, but backwards. So I'll start with the last term here. And then each subsequent term is going to be 3 smaller than the previous one because I've written it backwards. If you're going to add these up by columns, sorry, I didn't write it in a way where the columns line up, but you can sort of imagine. On the left, we'll get 2s. Figure out what you'd get on the right, figure out how to simplify it to have an equation for s. Go ahead and pause the video. Give it a try. All right. So if I'm going to add up these two, I get, let's see, it seems like 1 plus this other stuff is going to be 2 plus 3 times n minus 1. And then I'll have that same thing here and here and here and here. How many of them do I have? I've got n of them, so I can multiply by n. So that gives me s equals n times 2 plus 3n minus 1 divided by 2. That doesn't look particularly pretty. If we wanted to kind of step back and ask ourselves, where does this algebra really come from? You could think about it this way. You could think about it as being n times, let's see, this 2 plus this stuff. This was actually the first term plus the last term, right? Because that's how we actually got these divided by 2. And this way of thinking about it actually captures the pattern a lot better. And if this is how you'd been thinking about it originally, we wouldn't have had to even have written this out. You could have just immediately looked at this and then jumped straight to here. So that's the kind of thing I want you to practice with the algebra is, go ahead and do the algebra, but you always want to have your head up to notice, does part of your algebra have a special meaning? And would it be more insightful to write down an equation in terms of the things the algebra represent rather than the algebraic terms themselves? So if I wanted to write this, a little bit more nicely, I could say a sub 1 and a sub n, because remember, that's how we've defined the first term and the nth term. Okay, good luck on the problem set.